Well, good. It's great to be here in Singapore. My name is Jason Bloomberg. I'm president of ZapThink, which is now a division of Dovell Technologies. Dovell is a government contractor in the U.S., and they acquired ZapThink in the middle of last year, so now I'm a member of a larger firm. But ZapThink's been around for over 10 years. We were known as service-oriented architecture thought leaders, working with enterprise practitioners around the world, running our 4-day licensed ZapThink architect course. And now we're rolling out a new 2-day cloud computing course as well. And in fact, I'm running it here in Singapore tomorrow and the next day. So a little short notice for you folks, but I'll be running it in Singapore and then India in a couple of weeks, but it's taking it all over the world. So this morning I'm starting off with talk about REST-Based SOA. So how many people here know what REST is? Oh, nobody. Okay, one, two. Okay. Well, don't worry, we'll start at the very beginning. How many people here know what SOA is, service-oriented architecture? Okay, got a few more volunteers for that one. That's good. Okay. Okay, well, let's start with a definition of REST. So what is REST? Well, it stands for Representational State Transfer. And it's a mouthful, right? It's a long name, but there's a reason why it's called that. We'll talk about the state part of the story, and we'll talk about representations. So by the end, you'll understand why it's called that. So it's essentially an architectural style for building distributed hypermedia applications, such as the World Wide Web. So we'll talk about what hypermedia is as well, but essentially you can think of it as building applications that take advantage of the best practices of the World Wide Web itself. So if you look at the web, what do you see? Well, it's immense. Right? It continues to grow. No one person or organization is in charge, and it's enormously resilient, right? I mean, sometimes you have bad links, but overall the whole thing keeps working, right? It's very hard to take the web down, and it's infinitely scalable, right? It keeps growing, and we don't even know how big it is. That's how big it is. So the idea is, well, let's look at the web, and let's see if we can gather some architectural principles from the web that we can use in our own organizations to build applications that have the same properties. So who came up with REST? Well, this fellow here, Roy Fielding, he was one of the original creators of the HTTP specification, and he invented REST as part of his doctoral dissertation in 2000. And so he is essentially the progenitor of REST. So he established these principles. So if you're familiar with REST, and I guess only a few people are, it's broadly understood to be an HTTP-specific way of addressing resources on a network. But there's some myths, some things that people believe about REST that aren't strictly speaking true. For example, it doesn't necessarily depend upon HTTP, right? You could use other protocols. There's nothing specific to HTTP that requires that particular protocol. You could use other protocols if you wanted to, Jabber protocol, XMPP, or some others. But for all practical purposes, virtually all REST-based deployments are HTTP-based. So the question there is, in your organization, well, do you have HTTP everywhere? Maybe, maybe not. Is REST appropriate in those parts of your organization that have other transport protocols? Well, possibly, but in general, REST-based tooling is HTTP specific. Another question, and this comes up often in discussions of REST-based SOA, is that do you have to choose between REST or web services? And the answer there is actually no. In fact, there's a REST binding for WSDL in WSDL version 2, so you could do REST-based web services if you wanted. And one of the things we'll be talking about is how to do REST-based SOA with or without web services, right? It's really not a question of choosing REST versus web services, but REST is an alternative to SOAP, which is the transport protocol specific to web services, but you could pick different transport protocols as well. And then there's also the question of security. If you think about REST being HTTP specific, then you might say, well, are we going to use SSL then to secure it, right? We use SSL for securing HTTP interactions. And there's some problems with that, right? SSL is point-to-point, it's transport-level security, so you can't secure parts of messages, and if you have messages going over multiple endpoints, then you have problems with lack of security after it crosses one endpoint. But as it turns out, there are other security approaches that you can use with REST that use other technologies in addition to SSL. So the security problems can be solved as well, even though in many cases REST deployments use SSL, and that limits the flexibility of your security, but that's not necessarily the case. Okay, so when we talk about REST, there's a number of new terms that are part of the REST language. And if you talk to a RESTafarian, somebody who's really excited about REST, they'll be using this terminology. So let's define some terms. So first of all, REST talks about a resource, and a resource is essentially some capability on a server. So it's an abstraction of the server capability. So you can think of it as something your server does for you. So it could be a PHP script or some other code on a server that can generate web pages or other representations. So what's next term is a URI, Uniform Resource Indicator, and that's a string or identifier. That's a string that identifies a resource on a network. So it could be a URL, Uniform Resource Locator, or a URN, Uniform Resource Name. But essentially it's a string that identifies the resource on the network. So if you want to find it, you can use the URL. So that word representation is essentially what the resource gives you. So you can think of it as a web page, right? If you have a PHP script and your browser hits the server, it gives you back a web page. The web page is the representation of the resource, which is that PHP script. But it could be a web page, an HTML file, could be an XML file, could be a video file, could be a vector file, could be a JSON file, right? There are many different types of representations. And then the term hypermedia, right? REST is about building hypermedia applications. So what is hypermedia? Well, it's essentially an update of the term hypertext, right? Where hypertext was essentially a set of web pages with hyperlinks that link from one to the other. Only now it's not just web pages, it could be any type of media. So any type of media interconnected via hyperlinks is essentially what we call hypermedia. So again, it's still just a glorified website in that sense. Okay, so what is a resource? Well, it's anything you give a URI to, right? So if you can find it on the network, you can think of it as a resource. So it could be static or dynamic web pages, it could be documents or images or rich media of various sorts. So it could be API calls. You could have a web service be a resource as well. It's basically anything the server can do for you is a resource. So when we talk about a uniform interface, this is one of the key differentiators of REST. And this is where a lot of people get stuck because they see this as being central to REST. And it's important, but it's not the whole story. Right? The idea with a uniform interface is that we have 4 operations, and that's everything that a client can do to interact with a server. And they're get, post, put, and delete. So get and post are familiar from HTTP, right? If we have a web page and it's interacting with a web server, it can either get a web page or it can post a web form. And if you've worked in the web, these are very familiar. Well, put and delete are also part of the HTTP spec, and you can generalize these to other protocols other than HTTP as well. So the idea here is that these are the operations you get. And everybody agrees that these are the operations you get. So all you have to do to program your resource is make sure that you're responding to these 4 operations the way the client expects. So contrast that to web services where you define your operations any way you like, and now there has to be some way to discover the operations, and you have to go fetch your WSDL file from a repository somewhere to figure out what the server is going to do for you. Well, here it's get, post, put, or delete. Right? We don't have to look anywhere to find that out. Those are the 4 operations. That's all we get. So it's a uniform interface for all interactions between clients and servers. So here's an example of how this sort of thing works. Because one of the questions we often get is, well, what's the difference between put and post? Right? Post is familiar. If we have a web form, we want to post information to the website, we want to update some resource, we can use post. But actually, that's more of what put is for, right? Post is more for initializing a resource, and put is more for updating a resource. So here's a problem, right? The first example is if I wanted to use put to create or to update a resource, then I do put/resource, and then I put the ID, some sort of unique identifier for the resource. The problem here is that if I don't know what that ID is ahead of time, and I'm trying to create it with the put operation, then I may have picked some ID that is already in use, and I could have a problem problem that way. So instead, I want to post to the resource without specifying ID, and that tells the server, hey, create a new resource, and create a new ID for me, because now I want to have some particular instance of that resource to work with. And the server responds with a 201, that's an HTTP response code, saying, yes, okay, I created this resource, and it returns the URI of that resource with the ID that the server has now created for this particular instance. So the idea is now the client can now work with that particular resource because it has that information in a hyperlink from the server. And that's an important part of the story, right? That location actually is part of a hyperlink. Okay. So URIs can be either uniform resource locators. We're all familiar with those from the web, right? Those actually specify the resource as well as, identifies the resource. That's the zapthink.com port, and then also the means of acting upon it, the HTTP part, right? That URL tells me, oh, this is a web-based resource. I use HTTP to access it, and here's how to find it. Now, uniform resource names are a little less familiar. Those don't specify the location, but they're unique identifiers within some sort of naming system. So this is actually the ISBN, that's the international book number for the book that we published 6 years ago, and that's an actual valid URN. So that particular URN, if you were to look it up on Amazon, you would get our book, but it doesn't tell you anything about where the book is located on the internet. It just gives you a unique identifier in the ISBN namespace. So that's essentially URIs come in those two flavors. Okay, so one of the key best practices, and this is if you're a developer and you've been working with REST, this is one of those rules you can break, but you shouldn't. So the key best practice is to follow a RESTful approach to creating these URLs. Now the problem is that if we've been programming for a number of years, we're working in a systems environment, doing integration for a number of years, we tend to fall into this remote procedure call way of thinking about the world, an RPC-based approach, where we're trying to do distributed computing, so we think of that remote piece of software. How do we call it? Well, we call procedures. We think of it as having an API that has particular procedures, and we call those procedures. So the problem there is we have to know a lot about how it works ahead of time, and if we want to change what the server does for us, that might break things, and that's essentially what we mean by being tightly coupled, right? If we change something on the server, it breaks the clients. So an example of an RPC-based URL, it's at the top there, right? I have example.com/cart, that's the name of the resource, and then update cart, cart ID equals 47, right? So I name the operation, update cart, I name the parameter, cart ID, and I give it a value, right? Now I can get that to work, right? If you've programmed on the web, you've probably programmed URLs like this all the time. But the problem is that the client has to know all these details, and the server can't change how it behaves, right? The server's hands are tied, saying, okay, well, I have to update, I have to support this update cart operation, I have to take cart IDs, 47 has to be a valid cart ID, or I can't do anything with this request. So a RESTful approach, basically get rid of that question mark, get rid of the equal sign, get rid of the name of the operation. Right? All I have are get, post, put, and delete. So I do example.com/cart/47. So what does that mean? Well, it's whatever the client expects it to mean, and it's the responsibility of the server to respond appropriately. So if I'm getting that, I send a GET request to that URL. The server has to respond with what the client is expecting, along with all the other operations. So this gives us flexibility, because now if I want to update the server functionality, as long as the server is responding appropriately to these 4 operations, the interactions will continue to work. Okay. So what is a representation, right? It's like think of a web page, or it could be any kind of media type, any type of internet media type. So that phrase internet media type, you may or not be familiar with it. That's an update of the old term MIME type. Remember MIME types? That was the internet, it was an internet messaging type for email, for email attachments. Well, that's been generalized now. It's now called an internet media type, and it could be any kind of standard representation format. So these are familiar MIME types or internet media types, or text/HTML, text/plain, XML, JSON, etc. And the list goes on. And these are all standard internet media types that are well understood, and your software probably already understands them. And I put these little icons here because this is how a lot of operating systems identify document types, is by the media type. So that's how it knows. So that's a PDF, well, because it has the PDF media type. And so that would give you the right icon. Okay, so now what are hypermedia? Well, remember that what REST is for, it's an architectural style for building distributed hypermedia applications. This is the point of REST, is to build hypermedia applications. Hypermedia is just essentially a word that means a big website where you have many different types of media representations, web pages and image files and any kind of representation you like, and they're interconnected via hyperlinks. So the way you get from one to the other is you follow a hyperlink, and that creates essentially a hypermedia application, which is now an abstraction of a website. So the World Wide Web itself is an example of one of these, but the whole point of REST is that you could build your own hypermedia applications that follow these same best practices, and now you have all these great benefits that the web gives you for your own application. So, when we say architectural style, REST is an architectural style. That phrase architectural style has a specific meaning. What we mean by architectural style is a set of constraints. Right? So we have an architectural approach. We can do all these different things, to do an architecture, all these different rules we might want to follow. But when we say we're doing REST, that means that we're going to follow a particular set of constraints, and that means we're following the architectural style called REST. In the case of REST, we have 4 specific architectural styles: separation of resource from representation, manipulation of resources by representations, self-descriptive messages, and hypermedia as the engine of application state. Now we'll go through each of these in turn, but the point is that you have to follow all 4 of these to be doing REST. Does everybody who say they're doing REST follow all 4? No. A lot of people follow 1, 2, or 3 of them, saying, well, this is REST, or REST-like, or immature REST. And if it works, if it solves your problem, there's nothing wrong with that. Right? If you're solving the business problem, then you're doing your job. But it may not be REST. To do REST, you have to follow all 4. Okay, so let's go through each of them in turn. Separation of resource from representation. So remember, a resource, think in your minds like a PHP script on a server. A representation is the web page that PHP script might generate for you. Well, if you look at those are different as a rule. Right? A whole page of PHP and a page of HTML are different. Right? Now, sometimes they're similar, right? You might have a static file on a server, and you do a get on that, and you get that static file, and it looks just like the file on the server. But generally speaking, resources and representations are different, right? So resources live on the server, and they're responsible for certain things, and representations are what the server gives to the client, and those are responsible for other things. So in particular, the state of resources that's on the server should be invisible to users of the resource. Right? So resource state is something that the server keeps track of for all users. Right? So if I have this inventory management application and the number of widgets in inventory is something that all users want to know about, that's part of the resource state. How the resource maintains that should be transparent. Right? So if I'm a client, I don't care whether it's a SQL, a database, or a flat file, or whatever. It's up to the server to keep track of that stuff. All I need to know as the client is I can do get, post, put, and delete. And I can follow links to interact with the server. And that's all I need to know as the client. So the resource now provides the limitations, or hides the limitations of the underlying media and technology from the users. So if the user says, well, I really want a JSON file, and the server says, I can't give you a JSON file, then that's all it has to say. It hides all the underlying workings of how that decision is made. The second architectural constraint, manipulation of resources by representations. So the representation, think of the web page as displayed on the client, although it could be any kind of representation. So it could be a video file, it could be an XML file, a vector graphic file, it could be running in a mobile device, it could be running in a browser, it could be running on your refrigerator, who knows, right? It could be anywhere. That representation manipulates the resource. So what do we mean by this? Well, how do you actually submit information to a website? Well, you fill in a form and hit submit, and that does a post. That is how you control the resource. The representation is responsible for that. So the representation essentially contains information as to what the client can do to change the resource. So if you think about a web page, you think about a web form, well, essentially that limits what the client can do to the server, because the web form itself provides certain constraints on what sort of post information can be posted. So that representation essentially constrains or provides contracted information that limits what the client can do to the server. Okay. So the fourth constraint, or sorry, the third constraint, we're only up to number 3, self-descriptive messages. So each message, so a message is now the information that contains the representation. So the interactions between the resource and the representation on the client, or vice versa, requests from the client to the server. Each of these messages is essentially self-describing. It has all the metadata within the message that the client and server need to process the message. So, for example, if I'm a resource and I'm giving you a JSON file, I'm going to tell you, hey, this is a JSON file, right? Or if I'm giving you an XML file that has to conform to a schema, I'll point you to the schema so you can find the schema, right? So all that information is contained in the message itself, including state information. That's going to be an important part of our tools discussion a little later this morning, because that information is now going to be part of the message. So this is very different from how we do this with the web services-based SOA. In the web services world, we maintain this sort of metadata external to the message. In the contract, WS policy content or some other place, and we have to go find that metadata in our repository, and that's the only way that clients know how to interact with servers within the web services world, is by looking for that contract metadata external to the message. In the REST-based interaction, the metadata are internal to the message, so the message itself tells you everything you need to know. And this is important, right? Because if the power goes out, and then 10 minutes later it comes back on, and all you have is the message, you still know what to do, because all the information about what to do with the message is in the message itself. So, for example, the message will indicate whether or not it can be cached or not. And this is an important part of scaling hypermedia application, right? The resource might return some representation that can be cached. Doesn't change very often. So it'll say, hey, you can cache me on some proxy. And now the clients can fetch the cached copy of the representation until it expires from the cache. And the representation should make this explicit. So if you've worked with HTTP, if you built websites over the years, this is familiar. This is built into the HTTP spec. If you know the pragma tag, anybody here know and love the pragma tag in HTTP? That indicates whether or not the web page is cacheable or not. So that's part of the HTTP spec, is a way of indicating in the web page, you can cache me or you can't cache me. Okay, so now we're getting to the good stuff, the fourth constraint. Hypermedia is the engine of application state. This is the one that developers freak out over, right? They get to this one and say, I don't have a clue what this means, so I'm going to punt. I'm not going to even touch this one. The problem is, this is where REST really begins. Because REST is about building hypermedia applications and about transferring application state to the client in the form of representations. Because we have self-descriptive messages, we can put application state information in those messages so that the client can maintain the application state. So our state engine for the application is on the client. So state engines are nothing new. If you have a computer science background, I can sort of tell that you all pretty much do, right? The state engines, right, basically move an application from one state to the next. We want the client to do that for the application state. Now, the server still maintains resource state, but that's state that's shared across all clients. We don't want to share applications, we don't want to put application state on the server, because the more clients we have, the more state information we need to maintain. It's not scalable. But if we maintain application state on the client, then the more clients we have, the more applications we have, but every client has their own computer, right? So it's infinitely scalable, right? If we have 100 million clients, how many client computers do we have? We have 100 million, right? So that's where we want to put the application state. So when we say hypermedia is the engine of application state, we mean we're pushing state information to the client in the form of hyperlinks. So how do we actually run our state engine, right? How do we know how to move from one state to the next? Well, we know because we look at the hyperlinks in the hypermedia representation. So hyperlinks, you can think of them as very simple as, a link you can click, but of course it could be links that are clicked by computer programs, right? It's not necessarily that a human being is on the client. It could be another piece of software that is running the application for you. So it could be fully automated, but how does the client know what it can do next? Well, it got a representation from the server that has hyperlinks in it, and those hyperlinks, the hypermedia, that's the engine of the application state. That's how the application knows what it can do, is because it knows it can follow hyperlinks. And that's what we mean by a hypermedia application. Okay, so HadioOS, hypermedia's application of, engine of application state. Even though this is core to what it means to do REST, most developers don't get it. Well, what's the problem? Right? You have this whole discussion of REST. If you Google REST, there's this whole religious community of Restafarians, is what they call themselves, as though it was a religion. No, it's not a religion. It's just an architectural style. But they think they're following REST. But most of them have no idea what REST really is, because they don't understand HadioOS. They think REST is a way of building simple APIs using HTTP and with those four operations, uniform interface. As though that was the whole story. Well, from our perspective, that's like saying, well, I want to build this skyscraper, but I don't know how to build skyscrapers, but I do know how to mix mortar, so I'm going to mix a bunch of mortar. And now I know how to stick bricks together. And hopefully, if I stick enough bricks together, I'll end up with a skyscraper. Well, that's not a good way to build a building, right? You mix the mortar and hope the rest works out. No, you have to architect the building. You have to say, this is how you build a building, right? And then the mortar is a key part of the story, but you don't want to confuse the glue with the architecture, right? And building APIs is the glue that gets distributed computing to work, but it's not the architecture, right? REST is a style for building hypermedia applications, and those are the things you have to architect. You have to think about, well, what application do I need based upon the business needs? If the business doesn't need a hypermedia application, don't use REST. REST doesn't solve every problem. It's for building hypermedia applications. Not every application is one of those, so you have to know whether or not it's appropriate. Okay, so HadioOS in action. How does HadioOS work? Well, HadioOS dynamically describes the contract between the client and the server in the form of a workflow at runtime. So this is a key point. That's why I put it in red, big letters. Really big letters. So let's make sure we understand this, right? How does the client know what it's supposed to do? The server gives it representations with hyperlinks that are a runtime workflow. So what is a workflow? Well, it's essentially a business process with human steps where the technology interacts with people as they work their way through the process. Well, if you're sitting in front of a computer clicking links on web pages, that's a workflow, right? The application is the website, and the workflow is the sequence of web pages you click through. And it's a runtime workflow, because what are the links in the web pages? Well, it's whatever the resource gives you. Are they static? Possibly, but not necessarily. Right? If you've done any server web programming, right? If you're building a PHP script and you're building hyperlinks for the client to follow, those can be dynamic. They could be different for every single individual who goes to that web page. They might have different hyperlinks. If you go to your Facebook page, you'll see, a whole bunch of links in your wall or whatever. Well, it's different from the next person's. Everybody's wall is different. They all have different hyperlinks. But it's all the same web page, in the sense it's all the Facebook web page, but the workflow is a runtime workflow, and the hyperlinks dynamically describe the contract between the client and the server. That is, of all the things the client might do, it's constrained by the hyperlinks. So what can you do from your Facebook page? You can click the links, you can type in the fields, you can submit hit the submit button and update your status and things like that. That's all you can do. Why? Because that's all Facebook lets you do, because that's what it means to use Facebook, right? So that's the contract between the client and the server in the form of a workflow at runtime. Okay. So, key point here, right? These URIs, you can think of them being, they're generally URLs in the case of a web environment. They could be static or they could be dynamic. And how does the client know what they are? Well, the client simply has to have a starting point. One URI it knows to follow to get into the application. And what do we call that? A bookmark, right? Because that's what it is. That's what a bookmark is. A bookmark is a saved URI you use to start your interaction with an application, right? That's what we mean by a bookmark. So once you follow that bookmark, then it's up to the Hypermedia application to tell you what you can do next. And it might be different every time. Might not, but it might be different. It might be different for every user, depending upon what the application is supposed to do. So the links can be contextual, right? What you can click might depend upon what you clicked before. It might depend upon who you are or other context, other application state information. So again, the Hypermedia becomes the application state engine. So when we talk about internet media types, we talked about XML and JSON and HTML and some other PDF and some others. Well, those are all standard internet media types, right? And if you're programming at that level, you can go look them up. I think it's IANA maintains those, and you can go look them up and say, oh yeah, there's this obscure media type thing for this application, but you can come up with your own, called custom media types. So here's the standard format for a custom media type at the top here. Application/VND. VND stands for vendor, because the idea is that a software vendor would come up with their own custom media types, but it could be your own organization. You can be your own vendor. The .zap thing, just indicate that's us. We created our own media type. And this is our PO, so purchase order. Let's say I wanted to come up with a custom purchase order media type just for my customers. So it'd be vnd.zapthing.po, and I put the Plux XML because it's going to be in an XML format, but it's a custom schema for this particular media type. So the goal here is to put whatever sort of additional contextual information or semantic information into the interactions. So if I wanted to have this custom purchase order format with all of this semantic information about what it means to send a purchase order to my company, I can do whatever I want. This gives me the ability to put semantic information into these interactions. Of course, the downside is the client has to know about this media type ahead of time. But that's the way it is with semantics, right? Semantics is all about getting together in a room and agreeing on what you mean by terms. And REST doesn't solve that problem, but it gives you a formal way of putting custom semantic information into your interactions in the form of custom media types. So it's not the best solution in the world, but it's how REST does it. Okay. So this talk is on REST-Based SOA. So I've done an introduction to REST, but we have to talk about the SOA part of the story as well. And a key part of the story here is, well, what does it mean to be a service in the context of SOA? And what would a REST-based service be? So that would be a key part of REST-based SOA. Well, when we say service in the context of SOA, we mean a contracted service. Right? A service has a contract, so that specifies essentially the interactions between clients and servers that interact with in the context of that service. So where is the contract in a REST-based interaction? Well, the 4 operations, get, post, put, and delete, are part of the story. Right? If you look at a WSDL file, operations are part of the story, but there's more to WSDL, and there's more even in the web services world. It could be, WS policy, content, XML schemas could be part of the contract as well in the web services world. In the REST world, we have the 4 operations, but we also have the hypermedia, right? The workflow at runtime, and we also have contract information in the representations. So what do you mean by this? Well, here's the example. Let's say I want to fill in a form, right? So I'm the client here. I get some page that has a form on it. So what does the server do? It sends me a page with a form on it. And here's a piece of that, right? So there's a form tag. This is HTML, right? There's an action. There's the hyperlink. It has a method. There's the operation. And then what's next? A bunch of form fields, input or whatever, or text area, whatever. So a bunch of form fields. So the next thing, what can the client do now with that web page? They can fill in the form and submit it, right? Or maybe click a link and do something else. But if they want to submit the form, they're going to post to that URI, and they're going to have the post data is going to contain the information that they put into the form. So what constrains that? the form itself. So where's the contract? Well, it's in the operations, it's in the hyperlinks, and it's in the representation that constrains the next thing the client can do. Okay, so hyperlinks create the workflow at runtime. Contract metadata might be in representations to constrain further requests. Media types are part of the contract information, right? If the server says, this is HTML file, the client knows it can only do certain things because HTML only does so much. But if it's a different representation, you might have other different media type, you might have other interactions. And namespaces as well can be part of the story where it provides some of the contract information, especially if you have an XML interaction. If an XML interaction, there's a namespace associated with it, then so you know what the tags mean, that's also part of the contract information. So in the web services world, it's a WSDL file, WS policy content, sometimes SOAP, although you shouldn't use SOAP for the contract, and XML schemas. But you store all that stuff in your repository somewhere. In the REST world, this is where you find the contract metadata. Okay, so if you're doing REST-based SOA, you have to follow the rules of REST and follow the rules of SOA. Nobody's saying you have to do that. Right? The core principle is you should use whatever tools are right for solving the business problem at hand. It may or may not be REST, it may or may not be SOA. But if REST-based SOA is the right approach, what does that mean? Well, you should follow some key best practices. All endpoints, so these could be client endpoints, resources, topics, if you're using asynchronous interactions and you want to subscribe to some topic, they should follow a common URI format. Now, the REST does not necessarily require this, right? You don't have to follow a common URI format, but you should if you want to have a REST-based service. And this is something actually the US Coast Guard did with great success, so that's a key part of that Coast Guard story. All requests and topics should be handled on an intermediary. So we didn't talk about intermediaries, where we use the term client and server, but those terms client and server in the REST context, those are abstractions. Right? They aren't necessarily meant to indicate we have a client-server architecture. Right? That may be one kind of request-reply approach. That might be one way of doing it. But the client could be itself be a server for another request. Right? And we could have an intermediary that serves as a client for your resources on the server and then acts as a cache, acts as a server for other requests. So in REST-based SOA, we want to use the intermediary because we want to resolve all endpoint references on the intermediary. And this gives us the core abstraction that makes services in the SOA context loosely coupled, is that we're resolving abstracted endpoint references in a flexible way that gives us the flexibility of SOA. So intermediaries should do this resolution for you. So you have this common URI format that all endpoints have, and then the intermediary transparently to the client resolves them into the physical endpoint references. And this is where you have all the flexibility and power of SOA. But because these are REST-based endpoints, you have the benefits of REST as well. Every resource should have a contracted representation. You may have other representations as well, right? So the resource might give you some sort of contracted representation that basically is constrained based upon the endpoint reference, but there could be other representations as well. So it could be a web form, but you might fetch an image. And all it is an image, and that's fine too. But at least one of the representations should be a contracted representation. Now the payloads, that is the messages themselves, they may or may not be loosely typed. In the web services world, because we're conforming to schemas, we end up with strongly typed messages, and that limits our flexibility. Strong typing is essentially a compile time check. We want to make sure there's no bug in our program at compile time, but we want runtime checks to be based upon loose typing. Right? This is the way JavaScript works, right? Is it a string? Is it an integer? Well, I'll make up my mind later. If it looks like a string, it's a string. Looks like an integer, it's an integer, right? And I don't want to throw a compile time error at runtime. You may contain hyperlinks, right? Not every payload has to contain hyperlinks, but if I want to build a hypermedia application, it's going to be based on hyperlinks. And it may or may not conform to custom media types if I want to include custom semantic information in my interaction. That's more of an advanced capability. So most organizations don't do that, but it's part of the REST story if you do want to do that. Okay, so differences between web services-based SOA and REST-based SOA. And there's key parts of the SOA story, and we'll go through each of them. So contracts, right? There's a bit of review since we went through this. In the web services world, contracts are documents external to the participants, right? WSDL files are external to the server, to the client, right? They're stored somewhere else. They're fixed at design time, right? The WSDL doesn't change at runtime, but it's something you design as part of specifying the service itself. So how do you update a service? Well, you have to go through a governance-driven versioning process, which can be elaborate and complicated. And we spent a lot of time talking about this in our LZA course because this is one of the big headaches of web services-based SOA. In the REST-based world, contract metadata are in different places, right? The links, the media types, namespaces, and the representation context, right? Representation tells you what you can do next. And it's dynamic at runtime, right? So the contract can change however the server says it should change. It doesn't have to be, but it gives you a lot of flexibility. So you don't have to worry about versioning a REST-based service the way you do a web service. What about operations? Well, in the web services world, right, operations are specified in WSDL, and even though we realize we should have document-style web services, even a document-style web service has operations in the WSDL file, which still have an RPC heritage that gives us no end of headaches. And if you've worked with web services, the operations are where all the headaches seem to be, because every vendor does them differently, and you know, how many operations can you have, and you won't have agreement on. It's a big headache, right? Well, REST solves that problem. Get, post, put, and delete there, we're done. Okay, those are our operations. So we're able to avoid any RPC characteristics. All we're doing is sending and receiving messages. The messages are self-descriptive, and the clients know ahead of time what the operations are. So this gives us the flexibility of essentially freeing ourselves from the RPC mentality. What's the difference in how we deal with data in the web services versus REST-based approach? Well, in the web services world, data, if we're using document-style web services, they are constrained by the XML schemas, so they're strongly typed. Semantic information is largely manual. We can try including, you know, RDF in our web services, but that's a huge mess if you ever tried to include semantic information in web service interactions. So it's typically done manually. We have XML schemas that provide syntactic information, but semantics is largely not part of the web services story. In the REST-based world, the representations can be of various media types, right? So we're not constrained to XML. We can use it if we want, of course, but we don't have to. We can be strongly or loosely typed. Gives us additional flexibility. And semantic information can be specified in custom media types if we want. But as I said, that's an advanced capability, and it's not without its own problems. Right? It doesn't solve all the problems. There's data, by the way, in case you didn't get that. And what about handling state? Right? This is one of the key ones. The web services world, there's no good answer. Right? This is one of the huge headaches with web services, because where we put state information, well, we could try putting it on the consumer, the service consumer, either by using HTTP cookies, except that we don't necessarily have HTTP, or maybe we use WS addressing. Well, IBM sort of does that, Oracle doesn't, so it's a big mess. So we don't want to use the client. We could rely upon custom message headers, put state IDs into our SOAP headers. Well, that's not part of the SOAP standard. So we have to customize our message headers. So instead of using SOAP, we're using our version of SOAP. That's usually a deal killer, right? Because now we can't send messages to third parties. So what's the fallback? Well, it's the middle one here. We rely upon the underlying runtime. So we have a traditional ESB, which maintains state by spawning threads, which are short-lived objects. Now we have to write thread state to the hard drive, and we can't. If we try to integrate one ESB with another, we have all these headaches where you can't take a Java thread and ship it to some other runtime environment. Right? That's not the way threads work. So we're essentially locked into a particular particular traditional vendor approach to state. I think it's just a big conspiracy. Right? Because it's a way of the vendors saying, oh, they pretend they're doing SOA, but they're really locking you in. So that's why it's so cool to see how Fiorano does it. I'm not here to plug Fiorano, but this is where Fiorano is significantly different from all the other ESB players, is that they handle state differently. So the REST-based world, rely upon hyperlinks. That's it. Right? The messages are self-descriptive. All the state information you need is transferred in the message to the client, and Hypermedia is the engine of application state. Right? That's the story. That's why REST is such an important part of the SOA story. Okay, that's it for my talk, my first talk. So up next is a tool from Fiorano, and then I'll be back with a bit of the cloud computing story. So, there we are. Thank you. Oh, he's just stepping out, so I guess that means there's a time for questions. Yeah.
This was a very good talk. Thank you. Just a quick question. You mentioned that it makes sense to transfer a lot of state information to the consumer and let it scale out. So how does it balance in terms of that scalability versus security? Because a lot of times consumers cannot be always trusted, and state is an important part.
Well, that's an important point, right? It's sort of the common wisdom, or the common rule is you don't want to let the consumer or the client take responsibility for anything that could screw something up, right? Because you never know if your client is really a customer or just a hacker pretending to be a customer, right? And they can write their own browsers. Who knows what they're going to do, right, if the hacker gets a hold of them? So that's a key part of the story. And it's something we're actually going to talk more about in my second talk, because that's part of the cloud story as well. So one of the things I'll be talking about later this morning is how we maintain resource state on the server and application state on the client. And so the server still does part of the story, including some of the security part of the story, as well as any state information that should be shared across different clients. But one of the examples I'll use is how Amazon does this. If Amazon uses this approach, right, if you're in the Amazon shopping cart, if you view source, you'll see all the state information in the hidden fields in your web forms. And you could, if you're a hacker, you can go in and you can monkey with those hidden field data. And the worst that could happen is you'll screw up your own damn shopping cart. And it serves you right. But you're not going to be able to steal anything from Amazon or buy something you don't pay for. That sort of stuff is maintained on the server. But what's maintained on the client? Things that really belong to the client. Right? This is the client's application. If they need to do something on the server, like execute a credit card transaction or change your database or something like that, that's maintained on the server. So the worst that can happen is the client screws itself over, and it serves them right. You think about it. Any other questions? I mean, I'll be back up, so if you have more questions for me, there'll be more questions at the end. But yeah.
Just one question. Can REST operate on async mode?
Yes, absolutely the case. When we say client server, it's one of the points I wanted to make is those are terms that are abstractions. It isn't necessarily client server in the sense of request reply. And I put in that notion of topics because sometimes the interactions are one way. But it's something Atul will be talking about as well because, of course, they do asynchronous REST all the time.